Hello Year 7s. Today we're going to be looking at subtracting fractions. And I'll just activate my pen. So if you recall, last class we looked at adding and adding fractions, and I gave you some rules. So the rules that we use for adding are the same as the rules for subtracting. So that's something that you don't need to copy these notes down, because you should have printed out either the handout that I gave you in last lesson, or you've copied these rules down from the presentation in the last lesson. So if you remember, rule number 1, fractions must be in a proper or improper fraction format. So we've been doing that now for addition. Same thing for subtraction. We want to convert mixed numbers into improper fractions before we do any addition or subtraction. Rule 2, fractions must have the same denominator to add or subtract. So if you remember when we did addition, we made sure that we had a common denominator between the two fractions. And we did that by finding equivalent fractions. Okay, another thing that I just want to point out again is that whole numbers can be converted to fractions with a denominator of 1. For example, if I want to convert my whole number 4 as a fraction, it just becomes 4 over 1. So just remember that, okay? So you might have to add a fraction to a whole number, convert the whole number to a fraction, and that fraction will have a denominator of 1. Rule number 3, when adding or subtracting fractions, we only add or subtract the numerator. So if you remember when we did the addition, we only added the numerator. Because the denominators were common, they remain the same. And that's going to be exactly the same when we do subtraction. And finally, which is something that we do always in fractions, when we're doing anything with fractions, simplify your final answer. For example, if I've got 18 over 24, so if I've got 18 over 24, what needs to be done with the 18 over the 24 is I can divide the 18 by 6, and I can also divide the 24 by 6. Dividing by the same number, that's how we simplify. 18 divided by 6 is 3, 24 divided by 6 is 4. Also, I might have an improper fraction. My final answer needs to be changed so that it's a mixed number. 25 divided by 2. Well, I know that 2 times 12 is 24, so I've got 12, but I've got one remainder, and it's over 2, which is the original denominator that I had. So 25 over 2 is the same as 12.5. So these notes should already be in your books. So I'm going to move on. Subtracting fractions, and here are some of the examples that we're going to go through. Now, one of the things that I think I probably led you a little bit astray, and that was my fault, was the importance of setting out your calculations correctly. So today when we're doing subtraction, I really want us to pay attention with how we do this so that we're doing it neatly in our books and correctly. I will be asking some people to send through some photos of their workbook so I can see how they're doing it, but try and copy what's shown to you here today. So evaluate 8 21s over 5 21. So evaluate means to calculate and write your answer in simplest form. So we're going to go through and do this calculation. So what is expected of me with regards to setting this out? Well, the first thing we should do is our page should be really ruled with a margin down the center, so it makes sense for us to work down the page. So I would copy this into my workbook. I've got 8 on 21, or over 21, with 5 over 21. And in this case, I'll just go through my rules. Well, they're both proper fractions, so that's fine. Rule number 2, they both have the same denominator, so that's fine. Rule number 3, I'll just go ahead now and perform the calculation. So my denominator is going to stay the same, so I can put that in straight away. And my answer is going to be 8 minus 5 is 3. My last rule says to simplify. Now 3 over 21 can be simplified. Okay, how do I simplify it? What's my common factor between 3 and 21? Well, it's actually 3. So I can divide by 3 and I can divide by 3. My final answer is 3 divided by 3 is 1. 21 divided by 3 is 7. So my final answer is actually 1/7. So that's the way that I'd expect you to lay it out. I've got everything nicely in a line. It's a bit hard for me on my little gizmo that I'm using, but try and set everything up so everything's nicely aligned, okay? And we're going to work down the page. That's the way I want you to do it moving forward. Question 2. I've got 4/9 minus 1/3. Okay, 4/9 minus 1/3. Again, I'm going to go through and write this into my... Set it out the way that I'd expect you to set it out. So you're going to have 4/9, take away 1/3. First of all, I know that they're proper fractions, so that's fine. I don't need to do any extra work with regards to that. That's perfect how it is set up already. The next thing I need to do, is have a look and get a common denominator. So the way that I would get my common denominator is by writing my multiples of 3 and my multiples of 9. And maybe if we start off with a larger number first, I've got 1 times 9 is 9, 2 times 9 is 18. Okay, I've got 3 times tables, so I've got 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9. Actually, we already know in this case here that I only need to change the 3 because 9 is my is common to both. Okay, so I'm going to change this 1/3 so that it becomes a fraction where a denominator of 9. So the way that I would do that is I've got 1/3, and I'm going to convert it. I already know what the denominator is going to be. It needs to be 9, and that will be the same then. So what do I multiply 3 by to make it into a 9? Well, I need to multiply it by 3. If I do something to my denominator, I must do the same, and I must multiply it by the same. So 1 times 3 is 3. So 1/3 is equivalent to 3/9. Once I've done that, I can now actually rewrite my calculation. 4/9 hasn't changed, it remains the same. But the third has changed. The third has now become 3/9, so that's equivalent. I can now do my calculation. 4 take away 3 is 1. And I already knew that my denominator was going to remain the same as 9. So my final answer here is 1/9. Okay, and that's how you'd go ahead and actually do that calculation. So I suggest you pause and copy these examples into your workbook, please. Again, the set out is really important. Everything's sort of put in a line. I'm working down the page, except when I've added my multiples. So please pause and copy this. Okay, I'm going to move on. Example number 3. Evaluate 4/7 minus 1/3. So I would write that straight into my books. My workbook, if I was doing this, is what I'm expecting you to do. 4/7 take away 1/3 or 1/3. They're both proper fractions, so that's my rule number 1 has been satisfied. Rule number 2, I need to have a common denominator. So again, I need to think about how am I going to change these fractions, find equivalent fractions so that they have a common denominator. Well, the way that I would do that is I would have to write down my multiples of 3 and my multiples of 7. Now I'm going to start with the larger number again. I've got 1 times 7 is 7. I've got 2 times 7 is 14. 3 times 7 is 21. I'm going to stop there. I've got 3, 6, 9. These are my 3 times tables. 12, 15, 18, and 21. So we can see that 21 is my lowest common multiple, and it's going to become my lowest common denominator for both of these fractions. So now I need to convert my fractions. I need to make them equivalent so that they have the same denominator. So I'm going to have 4/7. I know my denominator needs to be 21 because that's my lowest common multiple, which is now going to become my lowest common denominator. What do I do to 7 to make it into 21? I need to multiply it by 3. What do I do with 4? If I've multiplied my denominator by 3, I must multiply my numerator by 3. So this becomes 12. I'm going to convert my third. So I've got a third, 1 over 3. I know that my denominator must be 21. Finding an equivalent fraction. What do I do with 3? What do I multiply 3 by to make it 21? I need to multiply it by 7. So that means that I must multiply my numerator also by 7. So 1 times 7 is 7. So now I've got two equivalent fractions, and both these fractions I can see that I've got 12 over 21 and 7 over 21. So now I'm just going to continue with my calculation. Just put my little equal sign in. I've got 12 over 21, subtract 7 over 21. I needed to get a common denominator, and I've done that. So these are equivalent fractions that now have a common denominator. I know in my answer that my denominator is going to remain the same, 21. 12 minus 7, or take away 7, is 5. So I've got 5 over 21. Now, can I simplify that any further? The answer to that is no. Okay, there's no common factor between 5 and 21. So you can pause and copy that into your workbook now. Example number 4. Okay, same deal again here. I'm going to write it down as I would in my workbook. I've got 5 over 3 minus 4 over 5. Now, one of these is an improper and the other one is a proper. That's fine. I can go ahead with that. The next challenge for me is to try and find, or not try and find, I must have the same denominator. So the way that we find our common denominators, we need to find our common multiples between 3 and 5. So I've got 3. What are my multiples of 3? What are my multiples of 5? I'm going to start with my large number again. 5, 10, 15. Okay, my 5 times tables. I've got 3, 6, 9, 12, 15. So 15 and 15. There's my lowest common multiple, which is now going to become my lowest common denominator. So I need to convert my 5/3 so that it has a denominator of 15, and I find equivalent fraction. So what do I do to 3 to make it into a 15? I multiply it by 5. 5 times 3 is 15. If I multiply my denominator by 5, I must multiply my numerator by 5. 5 times 5 is 25. So that's one fraction. I'll do my next fraction. I've got 4/5. I know that my denominator must be 15. And if I do that, I'm going to have a common denominator between both fractions. So if I multiply 5 by 3, I get 15. 5 times 3 is 15. Which means that I must multiply my numerator by 3. 4 times 3 is 12. So now I have two fractions that are common denominators. So I'm going to write my calculation out again. I've got 25 over 15, which is equivalent to 5 over 3, minus 12 over 15, which is equivalent to 4/5. Let's go ahead and do this calculation. So I know that my denominator is going to stay the same, 15, because it's common. 25 take away 12 is 13. Can I simplify this any further? No. Okay, so 13/15 is my final answer. Again, please, this is what I'm expecting to see in your workbooks as far as set out is concerned. Try and work vertically. I'm sure you can work a little bit neater than what I'm doing using this electronic pen. So pause and copy example 4 if you haven't already. Copy 3. Moving on. Okay, so 3/10 minus 2/9. So again, I'd write it into my workbook. So I've got 3/10 minus 2/9. So they're both proper fractions in this case. What I do need to do about is get a common denominator. So I need to think of my multiples of 9 and my multiples of 10. Okay. This time we probably can cheat a little bit because we know that any of my multiples of 10 are going to end up with a 0, and my multiples of 9 are the same. So you can write all your multiples out, but I know that 10 times 9 is going to give me 90. I know that 9 times 10 is going to give me 90. So I'm going to work with getting a common denominator of 90 in this case. So I need to now change this fraction, 3/10, and find an equivalent so that the denominator is 90. So what do I multiply my 10 by to make it a 90? Well, I need to multiply it by 9. And that means if I multiplied my denominator by 9, I need to multiply my numerator by 9. So 3 9s are 27. And I need to convert 2 9ths. Again, I know that my denominator has to be 90. What am I multiplying 9 by to make it into a 90? Well, 10. Which means that I need to multiply my numerator by 10. So that gives me 20. So now I can continue my calculation using my newly created equivalent fraction. So I've got 27 90ths, or 27 over 90, minus 20 over 90, or 20 90ths. So 27 take away, actually I know straight away that my denominator is going to be 90, because it stays the same. 27 take away 20 is going to leave me with 7. So I end up with 7 90ths, or 7 over 90. And that's the most simplest form. I can't simplify that any further. So you can pause and copy that into your workbooks. Next question, question 6. Again, I'll copy the example into my workbooks. I've got 4 fifths minus 2 sevenths. They're both proper fractions, so I've met my first rule. I just need to get a common denominator. So what are my multiples of 5 and my multiples of 7? Okay. 7, 14, 21, 28, 35. Multiples of 5, I've got 5, 10, 15, 20, 25, 30, 35. So it looks like 35 is going to be my common lowest common multiple between 5 and 7. So let's go ahead now and convert these fractions into equivalents that have a denominator of 35. So 4 fifths equals 35. My new denominator. What do I multiply 5 by to make it 35? Or 7 5s are 35, 7 times 5, which means I need to multiply my numerator also by 7. 7 times 4 is 28. I've then got 2 sevenths, and I'm going to find an equivalent fraction so that it has a denominator of 35. What do I multiply 7 by? 7 5s are 35. What do I multiply 2 by? I must multiply it by 5 as well. So whatever I multiply my denominator, I multiply my numerator. 2 times 5 is 10. So I've got 28 over 35 minus 10 over 35. So we can now continue the calculation using these newly created equivalent fractions. 28 over 35 minus 10 over 35. So I know that my denominator is going to remain 35. I've got 28 minus 10. I end up with 8. So my answer here is incorrect, because it shouldn't be 8. It should actually be 18. That's better. So 28 take away 10. Moving on. So this last example that we've got, we're mixing it up a little bit. We've got a mixture of addition and some subtraction in here. So we now need to think a little bit further. In this case here, same process again. Okay, they're all, in this case, they're all proper fractions. So I've met rule number 1. Rule number 2 is I need to find a common denominator, my lowest common denominator. So I write out all of my multiples for 3. So here my multiples are 3. my multiples of 8 are here, and my multiples of 12 are here. So I need to now think I need to look at them and work out what's my lowest common multiple, which is going to become my new lowest common denominator. And 24 is common to all of them, and it's the lowest common multiple. So I'm going to convert all of my fractions now to have a common denominator of 24. And again, same process, okay? 2 over 3 equals 20. 8 times 3 will give me 24. 2 times 8 will give me 16. Whatever I multiply my denominator by, I must multiply my numerator. So 2/3 is equivalent to 16/24. I've got 5/8. I want to convert it so that it has a denominator of 24. Well, 8 times 3 is 24, which means that I need to multiply my 5 by 3, which is 15. So 5/8 is equivalent to 15/24. And then I've got 7/12, and I want to convert it to a fraction that has a denominator of 24. So 12 times 2 will give me 24, which means I must multiply 7 by 2 to give me 14. So 7/12 and 14/24 are equivalent fractions. So using these newly equivalent fractions now, you can see of using the new ones that I've just created, they've all got the common denominator of 24, and they're all equivalent. So I've now met my rule. Common denominator is sorted. I can actually rewrite it now like this. Down here, I've got 24. It's going to remain 24. It's common for all of them. 16 plus 15 minus 14, which is all of my numerators. And I'll just work in steps here. 16 plus 15 will give me 31. 31 minus 14 will give me 17. And my denominator remains the same. So I've got 17 over 24. So that brings it to an end. Please ensure that you're copying the examples. Please ensure that you're setting out your workbooks as I've instructed in today's video. Might not have been as clear when I did the addition stuff, but please try and follow the set out as I've shown you today. Really important that we're completing the work in our workbooks first. In fact, you can see you need to do working out. You can't just sort of work these things out in your head. It becomes a little bit more complicated. So please do that. Check the lesson log. It'll tell you what work needs to be completed for today. If you've got any questions, please be sure to email myself or whoever's helping us in class. But I'll be able to reply to you as soon as you can. And I do get people that send me a screenshot and say, Mr. Adad, I'm not quite sure how to move on from here. That's fine. Send me a screenshot and I can help you on. I don't want you to get stuck on something. But double check your rules and maybe have a look at the examples to make sure that you understand how to do it. Thank you.